Moins une minute.
We are 1 minute to launch. We're live at the Ariane Space Center for the launch of 4 satellites for Europe's Galileo satellite navigation constellation for the European Space Agency and the European Commission, built by a consortium led by OHB. And they're travelling on board the 240th Ariane 5 heavy lifter. Our very best wishes to all the teams. Let's sit back now and watch the launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des 2 EAP et décollage Ariane 240 Galileo FOC-M7. La propulsion est nominale. Tous les paramètres à bord sont normaux.
There they go. Blazing a trail across the sky here over the spaceport, the Ariane Space Center. We're heading northeast out over the Atlantic Ocean. And we can hear the launcher as she flies over us here. We're about 20 kilometers from that pad. We reached Mach 1 after 45 seconds when we broke the sound barrier. And right now it's the boosters that are doing all the
Tous les
work.
paramètres à bord sont normaux.
She's telling us that everything on board is going to plan. They are providing 90% of our thrust right now. That's the equivalent of 12 jet engines, and their job is to push us away from the gravity of our planet. We need a lot of firepower to do that. She's telling us that the propulsion is going normally. Each booster is burning 2 tons of propellant per second, and that's roughly the equivalent of what an average car would use in a year, and they're using it in a second. Unbelievably, those boosters are burning at roughly 3,000 degrees Celsius, and yet the main stage is burning cryogenic propellant, which is at absolute zero. It's the coldest temperature you can get, so you can just imagine the complexities of balancing and keeping those 2 temperatures next to each other, the extremely hot and the extremely cold. It's a feat of human engineering. And she's announcing separation now of those 2 boosters. We don't need them anymore, and they can be jettisoned. There they go. Those were cameras on a previous launch. We've lost about 3/4 of our weight. The lighter we are, the faster we can go. And we're now burning the main stage. It's that grey section. It's a huge tank of cryogenic propellant, which is liquid hydrogen and liquid oxygen. It burns for about 9 minutes.
Tous les paramètres à bord sont normaux.
And in a minute we'll be looking at the launcher again, and we'll be able to see what we call the fairing. That's the front, the nose, if you like, of the launch vehicle.
La propulsion est nominale, tous les paramètres à bord sont normaux.
And she's telling us that everything is normal. Everything's going according to plan. So there you can see the fairing. That's the nose, the pointy bit of the launcher, and the fairing is the section which protects. And this protects the launchers, the satellites, from the rigours of the launch. Those rigours include the acoustic vibrations at liftoff, you can just imagine there that it's very loud. So our satellites are now exposed to space. We took off, you can see there, from the northeastern coast of South America, and Galileo is the... She's telling us that everything's going according to plan still. Galileo is the tracking station here at the Guyana spaceport, and you can see we're travelling northeast. SNA is the next tracking station to pick us up. That's a boat in the middle of the Atlantic, and then we'll be heading up towards the northwestern coast of Europe, and we'll be picking up the signal at the Azores. Let's find out more now about today's mission.
For this 11th flight of the year, Ariane is proud to welcome the two-day Ariane 5 VA240 Galileo FOC-M7 mission to deploy 4 more Galileo satellites for the benefit of our customer, the European Space Agency, acting on behalf of the European Commission. Ariane today reaffirms its company's important role in supporting European governments and institutions with independent, reliable, and available access to space.
This launch will place in orbit 4 more satellites in a series of 22 manufactured by OHB in Germany, embarking payloads provided by SSTL in the UK. 5 FOC satellite launches have already been carried out by Soyuz launchers, each delivering 2 satellites into orbit.
For this launch, a second Ariane 5 ES version dedicated to Galileo mission will be used, with in particular a different upper stage called EPS. The EPS storable propellant upper stage is powered by a reignitable engine that operates with MMH and 204 propellants, allowing reignition capabilities essential for required Galileo mission performance.
This launch campaign started in mid-September 2017 with the arrival in French Guiana of the first pair of satellites. All 4 satellites have undergone a series of tests and preparation activities.
For recall, the specific dispenser carrying structure has been designed by Ariane Group, allowing to support 4 maximum satellite masses of 738 kg each, which cover with comfortable margin the actual satellite masses for this mission.
This campaign has led to additional needs in coordination and technical operations. All these challenges were surmounted through excellent preparation, planning and execution, the experience gained in the previous Ariane 5 launch campaign, and especially thanks to the very efficient technical teams.
Finally, I would like to thank all involved teams, and firstly our customer, the European Space Agency project team, the satellite manufacturer OHB, and the CNES-CSG teams for their very efficient collaboration and fruitful teamwork, which allowed to manage the program and the launch campaign with a great professionalism.
Indeed. 7 minutes and 24 seconds into launch, and today is the 56th mission that Ariane will have performed for the European Space Agency. And during that film, we picked up the signal at the SNA tracking station. That's the one in the middle of the Atlantic, the boat. Bottom left is our altitude. We are 134 kilometers above our planet. The middle is the distance. That's if you were to draw a straight line along the planet from the launch zone to the position of the launcher. She's telling us there's 1 minute left of a burn on the main stage. And then on the bottom right-hand side, you can see there is our speed. We're traveling at an unbelievable 7 kilometers per second, not per hour, per second. And on the top right-hand, you can see there is our trajectory. That is the planned trajectory. And the white cross is the position, the actual position of the launch vehicle. Burning at the moment the main Vulcan engine. It's propelling the main stage, which is an extremely powerful beast.
Fin de propulsion de l'étage principal cryotechnique.
And we have switched off
Et
that
séparation de l'EPC.
engine, and we have separation there of the main stage, and we have switched on the engine now of the upper stage. So we're beginning the next phase of the flight. The upper stage.
De l'étage à propergol stockable.
She's saying the first engine switch on of the upper stage. So the upper stage has taken the wheel, and its job is to transport our satellites to their correct orbit so that we can release them absolutely precisely onto their orbit. And from there, they'll be heading off on their own in medium Earth orbit to their final slot, and they have to do that all by themselves. We have 3 orbits for anyone who's not familiar. Well, 3 main ones. We've got low Earth orbit, which is the nearest to Earth. We have medium Earth orbit, which is where these guys will be sitting, roughly 23,000 kilometers above our planet. And then we have an orbit called geostationary orbit. We're not using that one today, but that's where most of the telecommunications satellites sit, and that's 36,000 kilometers above Earth. The Galileo program is an important collaboration between ESA and the European Union.
A symbolic image at the European spaceport in Kourou, French Guiana, as the President of the European Commission, Jean-Claude Juncker, French President Emmanuel Macron, and the Director General of the European Space Agency, Johan Dietrich Voorne, stand in front of the Ariane 5 launcher, which will soon carry 4 more Galileo satellites into space. This launch will expand the Galileo constellation from 18 to 22 satellites. And it's the second time 4 satellites will be launched with an Ariane 5. As with all other Galileo satellites, these newest additions will fly in a medium Earth orbit some 22,000 kilometers above the surface. This is the penultimate launch before completion of the Galileo constellation.
The completion of the constellation will take place in the summer of 2018, where we launch the last Ariane 5 with 4 satellites, which will bring the total up to 26 satellites. So we have at that moment 2 satellites in reserve, and we will then after that start putting some extra reserves in space in order to be prepared just in case.
Although the constellation is not yet complete, it's been in operation for almost a year since the European Commission announced initial services on the 15th of December 2016. These services were the first step towards full operational capability and a first opportunity for the Galileo system to prove its worth. Independent measurements since have shown that in terms of performance, Galileo is the best operating positioning system in the world.
We are having a better performance than our 3 competitors from the US, which is the well-known GPS system, the Russian GLONASS system, and the Chinese Baidu system. So of course in ESA we are excessively proud of this, and it is now important that we keep building on this performance and hopefully keep at the forefront of the developments.
However, the work on Galileo is far from over. The European Commission and ESA are already working on the next generation of Galileo satellites and infrastructure. They aim to continuously improve the system and explore the boundaries of technological possibilities, while trying to meet market demand with potential new applications or services.
A number of areas, for example, which are coming is the so-called Internet of Things, which will require positioning in sensors. And these sensors have very little power and very little battery capacity, so we need special signals for that, probably. And in addition, another area which is of interest is autonomous driving, where satellite navigation is going to be a very important component, but where it needs to be integrated with all sorts of other sensors in cars in order to make sure that autonomous driving becomes a reality.
With more launches to complete the constellation and set up redundancies, Galileo's performance and availability worldwide will continue to gradually improve, keeping Galileo at the cutting edge of satellite positioning technology. Today, the only publicly owned satellite navigation system has also proven to be the best.
And joining me here in the commentary box is Eddie Yao. Eddie is the ESA Galileo head of the System Engineering Unit. Eddie, it's a real pleasure to have you with us.
Thank you. It's a great time to be here. Thank you.
Just a very quick rundown of what you do and what does that mean?
Indeed. Within ESA Systems Engineering, we're responsible for the actual original design of the system and the flow down of the requirements, as ESA is the system design authority. As part of the system architecture, we make sure that the requirements are all properly flown down and released down there to the people for procurement.
So just back to today's flights, we had the signal, the tracking station in Santa Maria in the Azores picked up the signal during that film. Quick recap of the flight path, Eddie.
So at the moment, the launcher is flying up over the northeast across the Atlantic. It's passing over then the west coast of Europe, and then we'll go up over Russia, and then back down again over the southeast of Asia.
And the ground stations are picking up the signal from Ariane, which sends its signals down to those ground stations as it flies over. And that process is called telemetry. Galileo started offering services last year. She's telling us that everything's going perfectly normally. Just quickly, what are the main services, Eddie?
Indeed, actually, the initial services started December 2016. Over that period, we've been providing already the open service, pure service, and a search and rescue. And then, since then, in the 1st of July, the GSA has become responsible for the actual operations for the service availability.
Let's take a look now at the GSA.
The mission of the European GNSS Agency is to ensure that users in Europe and around the world get the most out of Europe's satellite navigation programs. To do this, one of the agency's key responsibilities is to oversee the operation and service provision of Galileo. In addition to our headquarters in Prague, the GSA manages a number of important Galileo service facilities and functions across Europe.
The GSA operations and service team works with a team of experts at several centers. The Galileo control centers monitor and control the constellation, working as mutual backups. The European GNSS Service Center operates the Galileo User Help Desk and supports users around the clock. The Galileo Reference Center provides independent monitoring of Galileo's performance and the quality of the signals in space. And the Galileo Integrated Logistics Support Center provides repair and spare part provisioning for the Galileo ground infrastructure.
The GSA also ensures that Galileo signals are secure, including the Galileo Public Regulated Service, which is reserved for institutional users. We are also responsible for the Galileo Security Monitoring Center and ensure the functioning of the EU GNSS Security Accreditation Board. The agency also plays a key role in the development of applications and services, manages EU-funded research, and analyzes the global GNSS market. As a result of our work, today many devices are Galileo-enabled and are already making a difference to users across the globe.
So Galileo satellites are making our positioning better and better. She's telling us there's 2 minutes left, less than 2 minutes left on the upper stage burn engine. So the upper stage is indeed powering us. Its job is to deliver our satellites onto what we call a transfer orbit. And it's transferred because they will then travel afterwards on their own to their own final orbital slot. But the transfer orbit's roughly, I think, around about 23,000 kilometers. Eddie, how does Ariane know, how does the upper stage know what it's doing and where it's going?
Well, within the upper stage itself, there's actually an intelligence part to it. It's actually within what's called the vehicle equipment bay. It's more than just an onboard computer, it's actually a whole management system within the launcher itself. It analyzes the information from the engines, from the propulsion, it has a navigation system, and it makes the decisions on what is the best outcome to achieve its mission.
So it's a very clever piece of kit, and it's getting ready right now to switch off the engine. The onboard computer will send the command to switch the engine off when the system senses the correct orientation of the launcher. So basically, the launcher has to be on track, it has to be going in the right direction, it has to be on time. The computer is programmed to understand that it has to fly from 0 to 19 minutes and 50 seconds. That will be the cut-off time. And it also has to be at the right altitude. Right now we are at 1,117 and climbing, traveling at 8.88 kilometers per second.
Première extinction de l'étage à propergol stockable.
So she's confirmed we have the engine has now switched itself off and we have entered the ballistic phase. Eddie, what does that mean?
The ballistic phase is basically when the launcher is travelling without propulsion. The rocket is travelling already high enough and fast enough to cruise without the engines being on. It's on a celestial autopilot, if you will. This will continue actually for more than 3 hours. What you also see is that the upper stage is going on a gentle rotation. This is what they call the barbecue mode. It's exposing each of the satellites gently for a brief period to the sun, just to keep the payloads and the satellites warm enough while it's in this barbecue mode and while it's in this transition. We saw the liftoff 21 minutes ago, and it would be great to see a few replays of that and that beautiful launch.
Nous sommes en phase balistique et la manœuvre d'orientation se poursuit nominalement. Top. Allumage Vulcain. Allumage des 2 EAP et décollage Ariane 240 Galileo FOC-M7. La propulsion est nominale.
Voilà donc, avec l'extinction de l'EPS, on vous le disait, on rentre dans une phase balistique, Cathy, une phase qui va être longue, plus de 3 heures, et on se retrouve tout de suite après.
Oui, absolument Thierry, nous allons, I'm suddenly finding myself talking in French. We're going to be coming back to you just before we switch the engine back on again in about 3 hours time. So that will be 7 o'clock here in Kourou, that will be 10 o'clock at night in Europe. And what time in Paris?
23 heures pour Paris. À tout à l'heure.
11 p.m. in Paris. Bye.
Acquisition de la télémesure lanceur par la station de New Norcia en Australie. Le mode barbecue est toujours en cours et stable. Le mode barbecue se poursuit nominalement. La phase balistique se poursuit nominalement et la phase barbecue est stable. Début de la deuxième phase barbecue. Perte attendue de la télémesure. Tous les paramètres à bord sont normaux, phase barbecue en cours. À tous de DDO, la seconde partie de la chronologie va reprendre. Merci aux adjoints de rejoindre leur pupitre. Fin de la phase barbecue. Manœuvre d'orientation au profit du second allumage de l'étage à propergol stockable.
Hello again, welcome back to our live broadcast. Here we are at the Guyana Space Center on the northeastern coast of South America in French Guiana. We are 3.5 hours into the launch of 4 satellites for Europe's Galileo navigation system for the European Space Agency, ESA, and the European Commission. They lifted off from the pad 3.5 hours ago. And this was the liftoff. Eddie Yao is back in the commentary box. Eddie, you are the head of the system engineering unit. You watched your babies fly into the air earlier with your real eyes, not on the screen. What was it like?
It was an absolutely amazing thing to see. I have to admit, this is the second time actually I've seen a launch. It never ceases to amaze. I mean, first we saw a flash in the background. It was slightly clouded over, but you could still see very, very clearly. I mean, this is the sort of images that we had looking from the terrace. Then you saw the streak of light going up into the sky as the launcher was raising up, and it passed behind the clouds and then reappeared further up. Absolutely beautiful.
And of course you get the rumble.
Indeed. I mean, it got quite high, and only then, after quite a while, you heard this rumble just emanating through the tropical rainforest. It's a beautiful, beautiful and fantastic thing to see.
So after the liftoff, after 2 minutes, we lost our boosters, which were getting us away from Earth. Then we lost the fairing, which was protecting the satellites after 3.5 minutes, roughly. And then we lost the main stage, and the upper stage has been powering us up into space ever since. We had a ballistic phase lasting 3 hours, and we are getting ready to switch our engine back on. Now we can just see there that the upper stage is spinning. Eddie, why is that?
Well, actually, there were 2 things happening. I mean, one was the actual barbecue mode, which I think is now coming to an end. And actually, I think the satellite, or the launcher, I should say,
Second allumage de l'étage à propergol stockable.
Repositioning itself for the firing of the main engine. Obviously, the launcher was originally in the ballistic phase, which was providing an elliptical orbit. And now we've reached the top of that elliptical orbit, and the speed has dropped quite a bit. We actually need to circularize our orbit for this particular plane and for the constellation. That's why the firing of the main engine is very important just at this point.
And for anybody who is not familiar with the terms elliptical orbit, that means an orbit which is basically the shape of an egg, a sort of oval shape.
Indeed.
And so we needed to then turn our orbit into a circular shape to make sure we're going round our planet in a circular form. Just a quick reminder here of our speed and altitude. We can see those on the bottom of the screen. Altitude nearly 23,000 kilometers above the Earth. Here's a closer look at the future Ariane 6, the next rocket.
July the 16th, 2020. This is the date currently set for the first launch of the new Ariane 6. For ESA and European industry, the clock is ticking, and 2.5 years appears like tomorrow when it comes to developing launchers and building infrastructure. However, in the green Amazon jungle of Kourou, Ariane 6 is already a reality. The future launch pad is already well underway, and the infrastructure for Europe's newest launcher is taking shape.
We have Ariane 6 for competitivity, Ariane 6 for cooperation, and Ariane 6 for growth. Here is a demonstration. The European industries coming here to French Guiana, building with local industries the launch pad from where we will launch mid-July 2020 the first Ariane 6.
The most impressive part of the Ariane 6 launch site is the giant hole for the launch pad, which is now finished. Also visible now are the flame deflectors that will be on each side of the hole. Construction has begun on the 90 meters high launch tower. This tower has to protect and shelter the rocket until a few hours before liftoff. Some 600 meters from the pad, the future Bâtiment d'Assemblage Lanceur, the launcher assembly building, is being built. This is where the different stages of Ariane 6 will be assembled horizontally. This is a new approach, as ESA's previous launchers have always been assembled vertically. This change in method also reflects the changed role for ESA as regards Ariane 6. In the jungle of Kourou, the sound of cranes and bulldozers can be heard, as builders are now working from early morning until late in the evening in an effort to finish the launch site in time. Meanwhile, in Europe, the production of the launcher itself is due to start next year, with several tests of the new engines and boosters that have been developed for Ariane 6. However, Ariane 6 is not the only new launcher which ESA is building. There's also Vega C, the enhanced and more powerful version of the lightweight launcher Vega. Its first launch is planned for 2019. Despite the many challenges, the European Space Agency continues to go forward, securing its new launcher family with Ariane 6 and Vega C. Thanks to ESA and industry, Europe will remain a space power with a guaranteed access to space.
So it's an exciting future we've got there, and Ariane 6 will be taking over the launch of the Galileo satellites at some point, won't it?
Absolutely. Basically, we already have a launch targeted for summer next year, which will be an Ariane 5. Those 4 satellites are already ready. But then after that, as of 2020, we'll be launching additional Galileo satellites from an Ariane 6 launch. And those satellites, which is 12, are already starting procurement as we speak.
Now, as you may know, she's telling us that we have 2 minutes left of the upper stage burn. As you may be familiar, the launcher is sending signals to the ground, and those signals get picked up by the tracking stations, which are dotted along the flight path. Right now, we are using the tracking station in New Norcia to tell us what's happening on the vehicle. And those tracking stations send the telemetry back here to the CVI, which is the real-time visual control team. These are the teams here at the Guyana Space Center who collect the information coming down from Ariane. They do a quick selection to check how the flight is progressing in real time, and they then pass that information to the range operations manager, whose voice you're hearing today, Fleur, who is calling out the main events in the flight. And later, the teams analyze the information to see how the vehicle performed, and they can make adjustments to future flights. That process is known as the Level 0 flight evaluation, which takes place several weeks after the launch. So, 30 seconds of propulsion left on the upper stage. She's telling us that everything's going according to plan. Getting ready to separate numbers 19 and 21. Why 2 by 2, Eddie?
If we release a single satellite, then that would push the launcher in the other direction compared to the satellite. This actually goes back to Newton's third laws of physics,
Deuxième extinction de l'étage à propergol stockable,
where action and reaction are equal and opposite. And hence it would interfere actually slightly with the launcher itself. So we release 2 together, opposite each other, and then the launcher itself stays in its orientation.
So we've switched off the engine.
d'orientation au profit de la séparation des satellites Galileo 19 et 21.
And we are starting now the orientation phase, which is preparing us now to release our first 2 satellites. You can see there that all the twists and turns and movements on the CGI images have all been very carefully planned. We need to orientate the satellites so that we can drop them off to their correct orbit in space.
Indeed, actually, we are actually 300 kilometers just below the final orbit. This is actually the graveyard orbit that we normally deploy things in. We don't want to deploy things directly into the final slots, because then there's a risk of debris and other items which we don't want in the final constellational slots. So we start from our graveyard orbit, and then gently we float the satellites up to the final position, 300 kilometers higher.
Fin de la manœuvre d'orientation.
So she's telling us that's the end of the orientation maneuver. As I was explaining, we have to orientate the satellites in a very precise position so that they can then travel on that journey on their own, which Eddie has just explained. There's a very, very precise set of
Séparation
movements.
des satellites Galileo 19 et 21.
And we have separation of the first two satellites, 19 and 21. We saw them. We can see them on the right-hand side there, Eddie, moving away equally in opposite directions.
And indeed, and the other two are still attached to the dispenser.
As you say, we have numbers 20 and 22 attached, and those are going to take 20 minutes before we can start releasing those. Why is that?
Well, 20 minutes gives a little bit of time. Obviously, the first two satellites, once they've released from the dispenser, they're starting their switch on, they're starting the computer, they're checking out their systems and all their subsystems, and then after a short period of time, they will try and release the solar arrays so that they can get some power into the satellites themselves. Then after that, it'll start doing some maneuvers so that it can orientate those solar arrays to look towards the sun so it can get power into the satellites. This is all done by thrusters. So of course then the satellites will actually be moving. So we need to give a bit of time so that things can move away so there's no risk of collision. And this is all being monitored from the ground stations. So at the moment, the ground station is just monitoring two satellites. If the other two to deploy as well, then there won't be much time for them to do their monitoring and do their checks. So we give them a little bit of a breather from two satellites and then the next two.
Navigation plays a hugely important role in all our lives these days, quite often on a device in your pocket.
Galileo satellites orbit Earth at more than 23,000 kilometers. Yet the European Global Navigation System is closer than you think. The latest models of the world's leading mobile phone manufacturers now support Galileo to make positioning more accurate and reliable. Location has become the cornerstone of thousands of applications, including navigation, ride-sharing, localized information, gaming, and even life-saving emergency response. In areas where signals from navigation satellites can be blocked by obstacles, Galileo makes a real difference. Over the past years, the European GNSS agency has worked closely with chipset and handset manufacturers to ensure the smooth integration of Galileo. It not only provides additional satellites to improve positioning, Galileo is also at the heart of mobile innovation. In the future, using Galileo dual-frequency chipsets on smartphones would provide better resistance to multipath and therefore more accuracy. The mobile world is fast-paced and constantly evolving, and Europe's satellite navigation system is ready for the challenge. Although invisible to most, Galileo is already in your pocket. Check if your phone's using Galileo. Visit www.usegalileo.eu.
So that's interesting then, Eddie. We can use a website to check whether our device is equipped with Galileo. How does that work?
Indeed, there's this website, usegalileo.eu, where it lists a number of different tools, a number of different equipments, like mobile phones, farming tools, sea or air applications. And all of these receivers are now identified as using Galileo, and it's worth checking that if you want to know if your receiver can use Galileo itself.
I have to say, I think it's absolutely amazing how navigation has become such an important part in our lives. I remember even 10 years ago, it was something you had in your car if you had a very flash car, but not something that you had on your phone, that's for sure.
Yeah, navigation really has evolved quite a lot. If we look back at mobile phones, back in the early 90s, mobile phones were very large, heavy things. The batteries didn't last very long. They were single frequency and also a single system. And now if you look at mobile phones, they've really grown in a huge way, and you could do so much with them. navigation also is following a very, very similar path. If you look at the navigation receivers that we are using originally compared to the ones now, they have really gone from also single constellation to multiple constellations, and also now there is a chipsets available which will actually do dual frequency.
Now, once the satellites are released, the French Space Agency, the CNES, will be taking control of them for the early operations.
Eh bien, ce lancement va mettre une fois de plus à l'honneur la politique spatiale européenne. D'abord, ce sera un lancement d'Ariane 5, et Ariane 5 est aujourd'hui, bien sûr, le cheval de bataille de l'Europe spatiale, et un lancement d'Ariane 5 qui va mettre en orbite 4 satellites Galileo, et Galileo, bien sûr, c'est l'un des projets les plus emblématiques de l'Europe spatiale, un projet de géolocalisation. Nous avons déjà mis 18 satellites Galileo en orbite, 4 de plus, ça fera 22, donc Galileo, c'est une affaire qui marche. Nous avons décidé l'année dernière, le 15 décembre, de déclarer ouverts les services initiaux de Galileo, parce que maintenant, si vous avez un smartphone, un iPhone 8 ou un Samsung 8, vous pouvez avoir une localisation grâce à Galileo. Et par rapport au GPS que tout le monde connaît, avec le GPS, vous savez dans quelle rue vous êtes, avec Galileo, vous savez de quel côté de la rue vous êtes. Et ça, c'est fondamental pour tout ce qu'on appelle l'Internet des objets, le véhicule connecté, le véhicule autonome. Donc, il y a une multitude d'applications qui sont en train de se mettre en place. J'ai été il y a quelques jours à la première réunion des utilisateurs de Galileo qui a eu lieu à Madrid. On voit qu'on change de paradigme. La problématique, c'est bien sûr de fabriquer les satellites et de les lancer, ce que nous sommes en train de faire, mais la problématique qui s'annonce, c'est se servir de Galileo et de faire de Galileo le système de géolocalisation que le monde entier attend. Le CNES, en fait, est à l'origine de Galileo et de son signal unique au monde. Et d'ailleurs, l'un de nos collaborateurs, Roland Lestarki, a été récemment honoré puisqu'il a eu le prix de l'inventeur européen de l'année. C'était au mois de juin, d'ailleurs, peu de temps après, le président de la République l'a félicité sur le pavillon du CNES au Salon du Bourget. Et ce signal Galileo, il est absolument remarquable parce qu'il est beaucoup plus précis que le signal de système équivalent. Et puis, il a aussi une caractéristique remarquable, c'est qu'il permet la datation des événements avec une précision de milliardième de seconde. Et donc le signal Galileo, il est made in CNES, c'est un succès de plus à l'origine duquel le CNES peut s'enorgueillir d'être.
Quick reminder, we are just under 23 kilometers above our planet. We've separated our first 2 satellites. We still have our second 2 attached, and we are waiting for those to be separated next. Eddie, we've heard that Galileo switched on the services last year. We've had the initial ones. We've been hearing it's been going very well indeed.
Absolutely. Since we've had the declaration of initial services at the end of last year, our performance has been consistently better than 1 meter error. I mean, that's a very, very good performance. And as we add more satellites as well, our performance is actually improving, and also our availability. With the inclusion of these 4 satellites into the constellation, we go from an 80% availability up to more than 99%. That's a massive improvement in the availability of the system and the service that will be provided to the users.
What does that actually mean to me on a day-to-day basis?
It means that we'll be able to position ourselves and use our receivers to find things much more accurately in the receivers that we have.
So, for example, if I'm driving along, I can actually find the front door of a house I'm looking for rather than the area in the street.
Indeed, because our positioning capability will be better than 2 meters, is what we've seen.
So it's quite remarkable. We're going to go over to a film now to find out a little bit more about these initial services that Galileo is providing.
One year ago, Europe officially welcomed Galileo. With the launch of initial services, Galileo moved from a testing phase to providing live services. While initial services are just the first step towards full operational capability, which will happen when the Galileo constellation is complete in 2020, users are already benefiting from Galileo's positioning, navigation, and timing information. Today, 40% of receiver models are Galileo-enabled, as are many leading smartphone models.
For deliveries, we always need accuracy on the phones. We need our perfect position always on the map. A lot of our deliveries are in areas with a lot of offices and high buildings. In the past, we always had issues with the positioning, and now it actually works perfectly. This saves us time, and time is money, of course.
The Galileo satellites are adding value for surveyors. Galileo makes a bigger difference in cities and forests. And here in Estonia, it's very important as we have more than a half country covered by a forest. Galileo signals are more stable even in low-angle visibility, so especially good here in the northern region of Europe.
I usually use my mobile phone to find some places on the map. I used to find that my phone wouldn't work so well around tall buildings in the city center. But I've noticed that it's works much better and doesn't lose my position like before. And I heard that is because of a new European satellite system.
Thanks to the Galileo Search and Rescue Service, emergency responders can locate a distress signal faster and more effectively than ever.
It's almost unbelievable that a small beacon that fits in your hand can be localized globally. These beacons are the perfect solution because the distress signals can be detected and localized around the world.
With initial services, Galileo is just getting started. As more satellites are added and new services become available, Galileo will provide better coverage, better positioning, and an even better user experience. Galileo is a European Union programme, and the European GNSS Agency is dedicated to delivering valuable Galileo services and ensuring that space is linked to user needs.
So, talk us through what we're looking at here.
This is actually the upper stage, what we're seeing at the moment, and the two satellites are still attached on the upper stage, waiting to be released. You see it on the small screen at the moment, and it's not quite orientating it so we can see very clearly, but actually you have the two solar arrays which are still closed in on those two satellites, just on the side, and then you can see a few dots on the top there. That's actually the search and rescue antenna on the satellites itself.
We'll probably get to see those in a minute, actually, Eddie, because we can't see them very easily there. But I just want to let everybody know that the satellites actually have names. They're called Nicole, Zofia, Alexandra and Irina. How did they get them?
Indeed, there was a competition that was held quite a few years ago, and a number of children from the member states sent in a number of drawings, and then the winners of those drawings had their
And of course, OHB is in charge of a huge consortium of different companies and organizations who have built the satellites. Everybody down to the tiniest screws, the contractors making bits and pieces and parts. And of course, the payloads were supplied by the UK-based Surrey Satellites, SSTL, which is mainly owned now by Airbus Defence and Space. Eddie, I mean, ESA oversees designing the satellites and the overall project, and you're actually in charge of that. This is a huge task. What does it actually involve?
Well, ESA is the overall system architect, and ESA is responsible for the original design and development of the Galileo system. We're also responsible for ensuring that the system meets the actual mission goals and objectives that were defined from together with the EC. With such a large project, there are many interfaces and many entities and other organizations who are involved and working together with us on the particular project. So as ESA, as the system architect, one of the main activities we do is to maintain those system requirements and ensure the flow down of those requirements coherently to all the parties who are involved. This is very similar to a role of an architect from a home who's following all of the construction and all of the little parts like the bricks to make sure that everything meets the final vision that they had when they drew the whole thing together.
But it is such a vast project, and I'm always amazed really about how things sort of come together and all the teams working together. So, you know, congratulations to everybody for pulling this off. And of course you do as well have the other thing, which is you sort of have to have a bit of a crystal ball and look into the future, because the satellites have to live for 12 years. And this is, of course, one of the issues in space, isn't it? It really is... technologically, you guys are really at the cutting edge of research and development.
Indeed, I mean, satellite technology is at the forefront of many things that we do, and it's pushing industry to develop the latest items and the latest tools, and it keeps the European industry right at the forefront of the work.
So you can see, just to remind everybody, our altitude hasn't changed down there on the bottom left, because we are staying on the same plane to release our next two satellites, but we will be releasing them at a slightly different angle to stop them from bumping into each other. Our distance in the middle of the screen, we've travelled 15,000 kilometres from the launch pad if we were to draw a straight line across the planet. And we are travelling at just under 3 kilometres per second, and there's our trajectory on the top right-hand side. I mean, 3 kilometres per second is slower than what we were travelling at, because we were travelling at one stage at 9 kilometres per second. But it always amazes me, Eddie, things look like they're happening very slowly, but of course actually we are travelling incredibly fast.
Indeed, this is a relative speed, and everything from the space, it looks very, very...
Just to translate that for everybody, she said this is the last orientation maneuver now, getting ready for the separation of the next two satellites.
Just what we see here as well, it's nice to see that you see a large disc in the middle. That's actually the navigation antenna. Once the satellites are on the final station, those are the antennas which will be transmitting the navigational signals down to the users and down to our Earth. And also you see there just above the diamond shape item, which is the search and rescue.
Hang on a minute, let's just check that diamond-shaped item. So we're looking at the two satellites. You can see the long rectangles of the solar panels, and then just to the left above those, on the sort of top
right on the
left-hand,
tip, yes.
Those are...
You see a sort of six coils and then a circular disc in the middle.
Séparation des deux satellites Galileo numéro 20 et 22.
We have separation of the next two satellites, 20 and 22. Congratulations to all the teams, to all the Galileo teams, European Space Agency, the European Commission, to OHB, and all the teams who've contributed to making these satellites. We can see them moving away there, Eddie.
Absolutely, and now the launcher itself has done the main part of its particular job, and it has to start its activities for passivation and for the graveyarding.
So